Dr. T. Sudasan Ramaperumal. Today we are going to see about TCP. TCP is the Transmission Control Protocol. It's a reliable connection-oriented byte stream protocol. TCP is a reliable in-order delivery of the stream of bytes. It is a full duplex protocol, meaning that each TCP connection supports a pair of byte stream. TCP includes a flow control mechanism for each of these byte streams that allows the receiver to limit how much data the sender can transmit. TCP supports a demultiplexing mechanism that allows multiple applications programs on any given host to simultaneously carry on a conversation with their peers. TCP also implements congestion control mechanism. The idea of this mechanism is to prevent sender from overloading the network. TCP services. Stream delivery services. TCP is a stream-oriented protocol. TCP allows sending process to deliver data as a stream of bytes to allow the receiving process to obtain data as a stream of bytes. TCP creates an environment in which the process seems to be connected in an imaginary tube that carries their bytes across the internet. The sending process can produce the stream and the receiving process consumes the streaming. It's a full duplex communication. Multiplexing and demultiplexing will be take over in the TCP. Connection oriented service. TCP is a connection oriented service. TCP needs to be established for each pair of process. When a process at site A wants to send to and receive data from another process at site B, the following three phases occur. The two TCP establish a logic connection between them. Data are exchanged in both directions. The connection is terminated. Reliable services. TCP is a reliable transfer protocol. It uses acknowledgement mechanisms to check the safe and sound arrival of data. The TCP packet format is a 20 to 60 bytes length. TCP packet format here we have source ports and destination port numbers of the source and destination process. Sequence number contains the sequence number, that is the first byte of the data segment. Acknowledgement byte number of the segment the receiver expects next. Header length of the TCP header as a 4 by 2, and flag contains urgent data. Acknowledgement, push operation, reset operation, synchronized operation, termination of the TCP connection. Advertisement window defines receiver window size and acts as flow control. Checksum, it is computed over TCP header data, and pseudo header contains IP field. Urgent PTR is used when the segment contains urgent data, and often there can be up to 40 bytes of optional information in the TCP header. And connection establishment. While opening a TCP connection, the two nodes wants to agree on set of parameters. The parameters are starting sequence number that is to be used their respective byte stream. Connection establishment in TCP is a three-way handshaking signal. Client sending segments to the server containing its initial sequence number. Server responds with the segment that the acknowledgement client segment and specify its initial sequence number. Finally, client responds with a segment that acknowledgement server's sequence number. Data transfer. After connection is established, bidirectional data transfer can take place. The client and server can send data and acknowledgement in both directions. The data traveling in the same direction as an acknowledgement or carried on the same segment. State transition diagram. To keep track of all the different events happening during the connection establishment, connection termination, data transfer, TCP is specified as the finite state machine. The transmission of one state to another is shown in direction line. States involved in opening and closing a connection is shown in the establishment state. This is state transition diagram. Server invokes a passive open of TCP which causes TCP to move listen state. Client does not active open which causes TCP to send sync segments to servers to move to send state. When sync agreement arrives the server, it moves the sync received state, responds with the sync plus acknowledgement segment. Arrival of sync acknowledgement segment causes the client to move establishment state and sends acknowledgement to the server. When acknowledgement arrives, the server finally moves establishment state.